finally, in example 3e, we're going to find the exact value of the cotangent of negative 5 pi over 12. All right, so this one is slightly different than the previous ones because now we have a negative angle, okay? So I'm going to show you how you should deal with that, okay? We're going to get rid of it, okay? We're going to apply the even odd properties. So if you remember, cotangent is an odd function, so that means if you're taking the cotangent of a negative angle, you can pull the negative out front. Okay, so this is going to be the negative cotangent of positive 5 pi over 12. Okay, so the negative sign is still there, but now it's not part of the angle. So we can focus on finding two angles that add or subtract to be 5 pi over 12. Okay, once we compute the cotangent of 5 pi over 12, once we get that value, we will just multiply it by -1. That's what that negative sign is out there for, okay? All right, so let's talk 5 pi over 12. We need two numbers that multiply to be 5 pi over 12. So again, I told you, think of two fractions over 12, okay? What two numbers we need the numerators to add up to 5 pi? So what's going to do that? Okay, you can start trying different combinations. You can add or subtract. I'm going to try through addition. Okay, so I first thought of pi plus 4 pi. Okay, if you add across the top, you're going to get 5 pi, but you can't do this. Why? Because this one, 4 pi over 12, that reduces to pi over 3, which is on the unit circle, so that's fine. But pi over 12 does not simplify, and that's not on the unit circle. Okay, so we can't go that way. So let's try another combination here. I'm going to try this time, let's just bump it up. Let's do 2 pi and 3 pi. Okay, so if you add these guys, you have a common denominator that would stay 12. 2 pi plus 3 pi is going to give you the 5 pi over 12. And then when you reduce this, this is going to be pi over 6. That's on the unit circle. 3 pi over 12 reduces to 4 pi over, or sorry, what am I saying? 3 pi over 12 reduces to pi over 4. That's also on the unit circle. We are good to go. Okay, so we're going to use these two angles. Okay, so I'm going to rewrite this thing, okay, as the negative cotangent of pi over 6 plus pi over 4. Okay, those are my two angles. Okay, all right. Now, the next issue, this problem seems to have some issues. The next issue is that there is no sum formula for cotangent. If we go back to page 1, here are all 6 sum and difference identities, okay? You only see a sum formula and a difference formula for cosine, sine, and tangent. There's nothing for cotangent, okay? So we're going to have to pull another trick, okay? So what we're going to do here is we're going to use the fact that cotangent is 1 over tangent. So this is going to become 1 over the negative tangent of pi over 6 plus pi over 4. Okay, so this is a lot. All right, so this is the direction we are headed. So in the denominator, we will be able to apply a sum formula for tangent. Okay, so I'm going to do this step by step. There's a lot going on. You've got to do the expansion through the sum formula. Then you've got to multiply it by -1. Then you've got to do 1 over the whole thing. Okay, so I'm going to take it one step at a time so I don't make a mistake. Okay, I'm going to go over here to the bottom. I'm going to handle the tangent of pi over 6 plus pi over 4. Okay, so when I look at this, okay, this is going to be, I'm going to use the sum formula for tangent. Okay, so I'm going to have to apply tangent of a plus b. Okay, I'm going to go back to page 1 and grab that. That is going to be formula number 5. Okay, so this is what I need to be using. Okay, so I'm going to go ahead and jot that down. So this is going to be the tangent of a plus the tangent of b all over 1 minus the tangent of a times the tangent of b. Okay, that's what we're going to be applying here. Okay, so if you line up or match up this with this, okay, you're going to see that the a value here is pi over 6 and the b value is pi over 4. Okay, again, it doesn't matter here since we're adding, it doesn't matter which one is the a or which one is the b. Okay, so we're going to plug into this. Okay, so this will be the tangent of pi over 6 plus the tangent of pi over 4. We're dividing this by 1 minus the tangent of pi over 6 times the tangent of pi over 4. Okay, so we're going to go to our unit circle, find these angles, and compute their tangents. Okay, so if we go back, we've used pi over 4 a lot. Okay, so we already have that the tangent of 45 degrees or pi over 4 is 1. So that's good. That we've already done that. And now we've got to deal with the other angle. The other angle is pi over 6. But guess what? That's 30 degrees. And we already have that as well. Okay, and I unfortunately think I erased it. Okay, so let me see. I think I just got it back. Okay, so we have already used these angles, so I can just go ahead and use this previous information. Okay, so we've seen before, like I said, the tangent of 45 degrees, which is the same thing as pi over 4. Tangent of pi over 4 is 1. Okay, because again, you're just taking your coordinates here, square root of 2 over 2, and square root of 2 over 2. You're doing your y coordinate divided by your x coordinate. Since the coordinates are the same, you're going to get a value of 1 for the tangent of pi over 4. And then if you're looking at 30 degrees, that's the same thing as pi over 6. Okay, so tangent of pi over 6, you need to be focused on this yellow ordered pair. Okay, so if you do the y coordinate divided by the x coordinate, that's going to be 1/2 divided by the square root of 3 over 2. That comes out to be the square root of 3 over 3. Okay, all right, so let's plug this information in. Okay, so we're going to get that this is tangent of pi over 6 is going to be the square root of 3 over 3 plus the tangent of pi over 4, that is 1. And then in the bottom, it's going to be 1 minus tangent of pi over 6 is the square root of 3 over 3 times the tangent of pi over 4, that's 1. Okay, so we're getting something very similar to what we did last time. This is going to be 1 plus, you can add in either order, so I'm just switching in the numerator. This is going to be 1 plus the square root of 3 over 3. The bottom is going to be 1 minus the square root of 3 over 3. Okay, and remember, this is just the denominator. Okay, let me highlight this for you. Okay, remember, we ultimately have to compute this right here. Okay, what we have so far, this is the tangent of pi over 6 plus pi over 4. Okay, so now we still have to multiply the whole quantity by -1, and we also have to do 1 over that result. Okay, so we still have some work to do, so I will continue on the next page. All right, on the next page, I'm going to go ahead and put this whole thing together. Okay, I'm going to have to do 1 over the negative of 1 plus the square root of 3 over 3 over 1 minus the square root of 3 over 3. Okay, so let me just double check that that is right. Yes. Okay, so again, look in this yellow box. I'm doing 1 over. I have the minus sign out front, and then I have this other quantity. Let me color code this. This is equivalent to this. Okay. All right, we have to keep simplifying here. Okay, so like I've told you before, sometimes the algebra is the hardest part of the problem. Okay. All right, let's deal with the negative sign that we have to send through the bottom. Okay, so what you have here, we have the 1 in the numerator, and then we're multiplying a fraction by -1. Okay, what is the proper way to multiply a fraction by -1? Well, let's think about it. I'm going to write my fraction down, and then I want to multiply it by -1, which is the same thing as -1 over 1. Okay, so then you multiply across the top and across the bottom. Okay, so we're still going to have a 1 in the numerator. And then in the bottom, we're going to have negative 1 times 1 plus the square root of 3 over 3. The bottom is going to be 1 times 1 minus the square root of 3 over 3. Okay, so if I continue with this, okay, the 1 stays in the numerator. I'm going to distribute the negative sign here. Okay, so this is going to be negative 1 minus the square root of 3 over 3. Okay, the bottom is going to be 1 times anything is itself, so it's going to be 1 minus the square root of 3 over 3. Okay, and then we can go ahead and handle this complex fraction. Okay, if we have 1 over a fraction, that is going to flip the fraction. Okay, so this is going to become 1 minus the square root of 3 over 3 over negative 1 minus the square root of 3 over 3. Okay, all right, so we have to keep going. Now we have to rationalize the denominator because the denominator contains a radical. Okay, so what we're going to do, okay, as a first step to doing that, okay, I'm going to get a common denominator in the top and in the bottom. Okay, and we're on our way to get there. It takes some work, unfortunately. Okay, so let's start with the top here. We've got 1 minus the square root of 3 over 3. And this second term is a fraction. We'd like the 1 to be a fraction over 3. So we're going to write it as 3 over 3 minus the square root of 3 over 3. Okay, we're going to do the same thing to the bottom. This second piece here, negative square root of 3 over 3, that is a fraction. We'd like the negative 1 to be a fraction. Okay, it's going to be negative 3 over 3. Okay, negative 3 divided by 3 is negative 1. Okay, and now we have a common denominator in both the top and the bottom. Okay, so we can make one fraction in the numerator, one fraction in the denominator. So if we continue on, we're going to combine these pieces in the numerator. Okay, this is going to be 3 minus the square root of 3 over 3. The bottom fraction is going to be negative 3 over 3 minus the square root of 3. So if you combine it into 1, it will be all over 3. In the numerator will be negative 3 minus the square root of 3. Okay, now we can divide the fractions. Okay, so we'll leave the top fraction alone, change the multiplication, flip the bottom fraction. Okay, this 3 cancels with this 3. Okay, and so we are left with 3 minus the square root of 3 over negative 3 minus the square root of 3. Okay, to rationalize that denominator, you're going to have to multiply by the conjugate. Okay, so I need to multiply the top and the bottom by, okay, we look at the denominator. There's a negative 3 on the left, and then there's the square root of 3 on the right. Okay, there's a negative sign in the middle. We need to change it to plus. Okay, and that's going to be considered the conjugate. Okay, we're going to multiply the top and the bottom by this quantity, and it will get rid of the radical in the bottom. Okay, we're going to have to FOIL. Okay, so if you multiply the first terms together, okay, 3 times negative 3 is going to give you negative 9. Multiply the outer terms, 3 times square root of 3 is 3 square root of 3. Multiply the inner terms, negative times negative will turn this positive. Square root of 3 times 3 is 3 square root of 3. And then the last terms, negative times positive will give you negative. Square root of 3 times the square root of 3 is 3. In the bottom, we also FOIL. Okay, so we're going to have first term times first term. Negative 3 times negative 3 is positive 9. And then we'll have the outer terms, negative 3 times the square root of 3. That is going to be negative 3 square root of 3. And then the inner terms, negative 3 times the negative square root of 3 is going to be positive 3 square root of 3. And then we have to look at the last terms. Okay, negative times positive will give us negative. Okay, and then square root of 3 times the square root of 3 is 3. Okay, so now Remember, the reason we multiply by the conjugate is because it causes these middle terms to cancel, and then we're left with 9 minus 3, which is 6 in the bottom, okay? In the numerator, we can combine the -9 with the -3. That's going to be -12. And then here we have 3 square roots of 3, and then we have another 3 of them. So 3 plus 3 is going to give us 6 square root of 3. Okay. And then we're almost there because the radical is out of the denominator. We can take each term in the top and divide by the denominator. Okay. So our final answer here is going to be -2 plus the square root of 3. Okay, that was a ton of work. Some of these can get messy just from the algebra perspective. Okay, but that's how you can get there. I'm going to check myself, as you should do. I'm going to punch this solution into the calculator to get a decimal expansion. So I've got -2 plus the square root of 3. Okay, and then I'm going to go back to my trig function and plug it in. Okay, I've forgotten what we were even trying to compute. It was so long ago. So let's go back to page 3. We were trying to calculate the cotangent of -5 pi over 12. Okay, so in doing so, when I look at my calculator, I'm in degree mode. So I need to change this back to radian mode. Okay. And how do you put this in the calculator? Because we only have a sine, a cosine, and a tangent button. We just use the fact that cotangent is 1 over tangent. Okay, so we're going to put 1 over the tangent of -5 pi over 12. And I am so happy that we got the same thing because that was a really long problem. All right, so these sum and difference identities are really, really useful for finding exact values of trigonometric functions for angles that do not appear on the unit circle.